ahead in our chemistry unit, it's important to take a step back and look at our very first subunit of matter, because everything that we're doing is going to relate back to that matter unit. So what else do I need to know about matter, and why does it matter? Well, when you see what we have to talk about, you'll understand why. The different things that you need to understand about matter involve the element, a compound, mixtures, physical change and physical property, chemical change and chemical property. Now in this lesson, we are not going to talk a whole lot about physical change and physical property, as well as chemical change and chemical property, but we will revisit those as we move through this current subunit. Now if you remember, matter is broken down into two different categories: pure substances as well as mixtures. Now earlier we focused much more on mixtures than we did on pure substances, but as we start talking about compounds and molecules and how all of those things work, we're going to be looking more at the left side than we are on the right side. Now, if we break them down, pure substances are made up of elements and compounds, whereas mixtures, we have heterogeneous mixtures and homogeneous mixtures. Now, how are these related? Well, if you take a look at it, what is matter really? It's composed of one element or a combination of two or more elements. That's what matter is. So when we look at it more carefully, pure substances are basically the form of matter that has a definite chemical composition and distinct properties. So they're pure if you look at them that way. And again, that will be clearer here as we move on. Mixtures, however, are two or more substances, elements, compounds, or both, that are in the same place but are not chemically combined. So they can be separated. Whereas your pure substances, when they're together, they can't be separated. And again, I'll make that clearer as we move on. Now, remember that heterogeneous, the components that you're seeing can be separated. So heterogeneous is a mixture. But basically, it's a type of mixture where we can see the differences. Remember we talked about things like the salad, where you can see the lettuce and you can see the tomato and you can see the cucumber and the carrots. You can see the different pieces. They look different, and if you wanted to separate them, you could easily do so. When you look at a homogeneous mixture, the composition is very uniform and they all look much the same. So it's really difficult to separate it. It can be separated physically, but it is more difficult to do so. Because these two can be separated right here, that's what makes them mixtures. If we can physically separate them, they are not pure substances, they are mixtures. So what does that mean? Well, when I look at an element, it is the simplest form of matter. It can't be broken down any further, and the atoms of all elements are basically look just about the same. So when I have an element, it is made up of all the same types of atoms. Now a compound is also a pure substance, but it's made up of two or more elements chemically combined in a specific ratio. So like salt, NaCl is a good example of this. And the reason it's not a mixture is because these are locked together by a bond. So we're going to talk about that again as well. Now, to be more specific, an element is a pure substance of the simplest form. They can all be found on the periodic table of elements, and they're made up of the same type of atom. So for example, the element helium, or for that matter carbon or hydrogen or any of the elements, basically each of those have their own type of atom that are all the same. So helium, for example, every helium atom has 2 protons. If you remember, that's what makes helium helium, is the number of protons it has. Whereas something like carbon has 6 protons, so every carbon atom making up that element of carbon, they're all going to have the same 6 protons, or 6 protons in each one.
Wow.
Now a compound is 2 or more different elements that have chemically bonded together, so we cannot physically separate these things. So if you think about it in terms of something you might be familiar with, if you think about compound words have different identities when they are separate, but when they are put together, they actually have a new identity. So to know means like that you obviously know something, and allege, when you have those two things separate, they have different meanings, but when you put them together, it means knowledge. So individually, they have maybe similar properties, but they are different in general. When they're put together, they actually have a combined property. and have a combined meaning. Light and house, when you put them together, it creates lighthouse. So much like elements of a compound, each element is going to have an individual set of properties, individual identities, and when they're put together, they're going to change their identities. So camp and fire, creating campfire, and hopefully you're getting the idea here. Now, some examples of compounds that you're familiar with are H2O. So hydrogen by itself and oxygen by itself are both gases. So they both have that as a property. But when you put two H's and an O together, you end up with a liquid. It's water. It's something that we understand as water. And it can be in different forms, obviously. It can be a solid, it can be a liquid, it can be a gas. But in general, they have different properties. We could drink them. By themselves, they're flammable or explosive. Okay? When you look at sugar, the chemical formula for one type of sugar is C6H12O6. So 6 carbons, 12 hydrogens, and 6 oxygens combine to create sugar. Now again, these are locked together, and we know that because there's no pluses in between them. So if there were pluses in between, then it would indicate that they are not locked together in a bond yet. So they're not really chemically combined. They're definitely their own individual elements. Now salt, Na and Cl, that's basically what you put on your French fries or some of the food that you eat. But Na by itself, as you'll see in just a moment, is a metal, whereas chlorine is a gas, and it's a toxic gas at that. So what do I mean by that? Well, if you think about it, a compound is always going to have a specific atom ratio. So for example, H2O, which is water, water is always going to have 2 atoms of hydrogen for every 1 atom of oxygen. So that's how water is made, and it's going to keep that ratio. And compounds always have some sort of ratio, and it's specific. So again, they have distinctly different properties from the elements that produce them. So again, as I gave you the example earlier, Na, which is sodium, is a silvery metal. Chlorine is a yellow-green gas, but when you put them together, they create table salt that has a definite and constant composition throughout, but very different than the original parts. Now, I want to show you a really quick video of how sodium and chlorine react together.
This is a lump of sodium. When it gets really hot, it melts. If you mix it with a jar of chlorine, a reaction immediately takes place to form sodium chloride, or common salt.
Pretty cool is what I think. That should about do it for today. We will be continuing on with our discussion about molecules and compounds, just so that you can get an idea of some of the different things that are out there and how they're made. We'll see you next time.